Okay, Aubrey, we're getting all sorts of interruptions today. 310, perpendiculars and distance. All right, we were talking about the airplane. Let's rock and roll. Shh. Give me some, like 15 minutes of your undivided attention. Here we go. Here's your airplane. And when we're talking altitude, you got to listen. When we're talking altitude, you're measuring straight down, right? It would be silly to measure altitude at an angle, right? But you want to measure it straight down perpendicular with the sea level, right? Okay? So like your 35 or 30, whatever it is, 35,000 feet or whatever it is, right? Right? Okay? So like 6 miles, 7 miles in the air, whatever you are, right? Anyway, okay? They will tell you that that's the altitude and they're measuring straight down. All right, now, here is where this comes into play. Sometimes, or in this section, we will be measuring, like let's say this is my line, right? And let's say I have a dot here, okay? And I'm trying to measure how far away that dot is. Listen. I'm trying to find how far away that dot is from that line, right? And a lot of people look at that and they're like, okay, it's this far. But that's a problem. You got to go perpendicular. You got to go this direction, and that's the distance between those two lines, right? Or that between that dot and that line, okay? So even though it would be nicer, Simon, turn around and listen. You boys in the corner, be quiet, okay? Even though it would be nicer to count straight down and just count how many like units that is, I have to go perpendicular, okay? One more thing. Let's say I have a coordinate plane right here. And let's say I have my two lines are going like this. And I want to know how far apart those two lines are. And this one is intersecting at 2, and this one's intersecting at 7. It would be really nice for me to be able to just say they're 5 units apart. But that's not how far apart they are. They are this far apart. Is that going to be more or less than 5 units?
87.
Less, right? It should be less than 5 units, okay? Because that's the shortest distance, is perpendicular. So we got to keep in mind that it's not just the vertical distance. It is perpendicular to each one of those lines. Got it? That's the hard part. That's where this gets icky. All right, here we go. Distance between a point and a line. They said if my point is at C, I can measure a lot of different ways going to that line, but the shortest distance is from C to D, right? Perpendicular to that line. Okay, because if that's an airplane, I'm going to measure straight down. All right, go to example 1. Go to example 1. Go to example 1. All right, here we go. Go to example 1. Shh. All right. I'm going to not read the paragraph, but what the paragraph is saying, I want to find the distance between this guy and this line, right? And it would be really nice if I could just say 1, 2, 3, 4, 5 units, right? But that doesn't work because I have to go perpendicular, right? I have to go a perpendicular line. So something like this, right? I don't know. Now, here's the deal. I want to be exact when I do this, right? I'm going to look at this line, and the first thing I'm going to do is I'm going to find the slope of that line, right? So going from this dot to this dot, I'm going up 2 and over 4, right? So my rise over my run for that line that's already there is up 2 and over 4, or 1/2. All right, now, that is this line. If I draw a line that is perpendicular, I know the slope of this red line has to be the negative reciprocal of 1/2, right? Which has to be what? -2, okay? So from this dot, I'm going to go down 2 and over 1, and down 2 and over 1, and down 2 and over 1. Ah, it's hitting perfectly right here and right here, okay? This dot right here, this black dot is at 3, 3, right? That black dot's at 3, 3. It hits nicely at 3, 3, yeah? Okay, so how do I find this distance then?
You calculate it.
Distance formula, right? I'm doing the distance from 1, 7 to 3, 3. Yeah? Distance formula. All right, square root of this guy squared plus this guy squared. Okay, how far apart is 1 and 3? 2. How far apart is 7 and 3? 4. Don't hit the wall. That's driving me crazy. Okay? All right, 2 squared is 4. 4 squared is 16. That's the square root of how much? 20. And the square root of 20 is, somebody give it to me in a calculator. Like 4 point something, true? What's the square root of 20? You think so?
I bet it's 4.7.
Distance formula is the square root of those things squared, right?
A squared plus B squared equals 4.
Yeah, this is how you find distance formula, Kellen. And then I look and say how far apart is 1 and 3, so 2 goes here. How far apart is 7 and 3, that goes there, yeah, yeah. What is it, 4 point what? 4.47? Cool. So this distance right here is 4.47 units, got it? That's how far that dot is away from that line, yeah? 4.47 units, that is, I don't know. They don't give me the answer. Oh, yes, they do. Oh, yes, they do. It's all the way down here, and it took them for darn ever, okay? Don't do it the way that they do it, because they have like 7 steps, okay? 4.47, good? Okay. All right, let's do this one real quick. This one is the check. Should I make you do it on your own?
No.
Okay, then be quiet while we do it together. This is the check, which is right above example 2. Find where we're at. We're going to do this together. Okay, this dot right here, I'm trying to find the distance from that dot to that line. It would be really nice if I could count straight down, but I've got to go perpendicular. I've got to go this way, right? At a 90-degree angle, okay? So, first things first, I want to shush. I want to find the slope of this line, okay? But we're going by 2s. So we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 9?
Over 9.
And over 9? No way. Down 9 over 1 over 9. Which is a slope of -1. So this guy's slope is -1. All right, if I do this one, my slope has to be the negative reciprocal, right? So he has to be a slope of 1. So up 1 over 1, up 1 over 1, and he's going to hit perfectly right here at, what's this dot? -2, 0. Now what do I do? Distance formula between those two. So the square root. I'm doing the square root of, how far apart is 2 and -2? 4. What about 4 and 0? 4. 4 squared is 16. 4 squared is 16. That's the square root of 32, which is 5 points. What? I'm going to say 5.7.
5.7.
5.7. Nice. 5.7. So that is how far. Does that look like 5.7? I don't know. Yeah, it's also going by 2s, right? So that looks closer, right? 5.7. Got it? Okay, let's skip that one. Let's go to... Oh gosh, we don't have a graph. Okay, here we go. Example 3. You got to flip a couple pages. I'm skipping a lot. This is the last example, example 3. Ready? Last example, example 3, and you need to graph. I'm going to give you guys some graph paper so that you can do this, okay? Here, and if you don't have them graphed, you get them wrong, right? You only have 7 homework problems. Quit complaining. Here we go. All right, here's my graph. Put them down on your paper. Underneath of example 3, just down in this corner right here, okay? I am graphing. Shh, there is a lot of extra talk going on. Be quiet, please. Let me get through this. Shush. We're going to graph this first one. Okay, it is already in slope-intercept form, -3x minus 5. Where do you start?
-5.
-5. Where's -5 located? Like -5 here?
No, down.
No, down, -5. 1, 2, 3, 4, 5. -5, I'm going to put a dot. And then the slope is -3, so down 3 more and over 1. Or up 3 to the left 1. Up 3 to the left 1, yeah? Like that? Okay, this is my line. That's the first line. Got it? Oof, that's really terrible. Anyway, whatever. Okay, next one, -3x plus 6. Yeah? -3x plus 6. Okay, so here I'm going to start at 1, 2, 3, 4, 5, 6. I'm going to put a dot. I'm going to go down 3 and over 1. And down 3 and over 1. And down 3 and over 1. And I keep going, right? Okay, and I draw my line. Okay? Now, I'm trying to find the distance between those lines. Shh. 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 I'm trying to find the distance between those lines, and it would be really nice if I could just count Because I know that this is at -5 and I know that this is at +6, so there's 11 units between them, but that's not right. Correct? I have to go like the distance this way, right? Or the distance this way. It's like the rungs on a ladder. True? So I get to pick where I want to go from, right? Okay. Let's pick, I don't know, I like that it's touching right here really nicely. Do you see this dot? I like it's touching right there. Where is that located at?
Or 2.
2, 0, right? Because this was at 6, and I'm going down 3 and over 1 and down 3 and over 1, so that would be 2, 0, right? Okay. All right, now, here's the deal. What was the slope of each one of these lines? -3 and -3, right? So if I draw a perpendicular going this direction, his slope has to be +1/3, right? Up 1 over 3, right? Or down 1 to the left 3, down 1 to the left 3, right? Okay. Is that going to hit where this dot is? That'd be really nice if it did. I don't know. Does it? This guy's at -5. If I go up 3 and over 1, that is like at -1, 2? No. -1, -2. Is that true? Is this at -5 to begin with?
Yeah.
And we're going up 3 over 1. So -1, -2, right? Okay, but this is +2. So I have to go, oh gosh, up 1 over 3. Is that going to hit in the right spot?
Yeah.
Okay, all right. I cannot figure this out if you guys don't shut your mouths. I have been saying that this whole class period, and you cannot figure it out. I will just make you go to the hall, and then you can do this after school with me. I will gladly teach it to you twice. Shut up. Okay, we're at 2, 0 over here, and we want to go 1/3 as our slope, which means I've got to go down 1 and over 3. If I go down 1 over 3, I am at, I don't know, like -1, -1. But that's not going to hit that dot, right? So it's not going to hit nicely. Should I pick a different spot? Let's try here. It's still not going to be nice, but let me try here and let's see if this makes it better. No, that's still not going to work. It's going to be gross numbers. Gross numbers. Yeah, 39, blah, blah, blah. I don't want to do that. 3.3 and -9. Ugh. Let's do a homework problem together, shall we?
Yeah.
Okay, I know you're excited about that. Because I made sure the homework problems go really nice.
We need graph. Can you give us
Do you want graph paper real quick?
please.
Okay, we'll do 13 together and then we'll see if you can figure out 14. Okay, 13. Yeah, except 13's in the back of the book and I know that's how you're going to do that problem. So we'll just do it together.
What? You can't prove it.
Odds are on the back.
There's answers in the
Worrying
back
out
of
is
the book.
you.
We'll do 13 together.
But they're
So immature.
but this is easy.
There you go. Will you hand that to them?
Oh, I have one.
Yes. And will you hand this back?
Why, thank you, Coach.
You're so
This
welcome.
should be infinity.
Here we go. 13 together. We gotta graph these.
These ones are only gonna stay the square or 72 apart.
You think so?
But
I don't know. I don't know.
you tell me if I'm wrong.
You might be right. I bet you probably are. All right, let's graph these two. They're already in slope intercept form. Pick a graph. I don't care. Yours is going to be nicer than mine. Where do we start the first one? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I put a dot. What?
I'll just do 2 first.
Well, go by 2s or something. I don't care. I'm sorry. Whatever. Just go by 2s. It's fine. 9. And then we go from there. What's the slope? 1. So we're going up 1 over 1, up 1 over 1, or down 1, left 1, and he goes like this. Okay? Just like that. Got it? The second one, where do we start him? At where? 3. 1, 2, 3. And I go up 1 over 1, up 1 over 1, or down 1, left 1, etc. Just like that. There's my 2 lines. And this is at 3, and this is at 9. It would be really nice if I was able to just find the distance there, which would be 6, and call it a day. But not true. Right? That would be 6 units. I want to go like, I don't know, I can draw a line wherever I want to, but since this hits at 3 really nicely, let's go this direction. Can we do that? Or we can start at the 9 and go this direction. I don't care, whichever one you want.
Let's do the first.
The 3? Okay, sure. We'll go off of the 3. That's fine. Okay? So this dot right here where they touch first is at 0, 3, right? Okay? I need to figure out where it's hitting there. Got it? Where are they meeting? At that spot. I need to figure out where that's at. Right? Now, here's the deal. Each one of these guys had a slope of how much?
Boy, I am wrong.
1. So this guy's slope needs to be -1. Or in other words, up 1, left 1, up 1, left 1, all right? Now, here's the deal. If I go up 1 and to the left 1, where am I at right here? If I go up 1, left 1. Up 1, left 1. From 0, -3. If I go up 1 to the left 1. -1, 4. If I go up 1, left 1 again, I'm at -2, 5. If I go up 1, left 1 again, I'm at -3, 6. I don't know if that's where they're going to meet. If this was at 0, 9, and I go down 1 over 1, now I'm at -1, 8. I'm at -2, 7. I'm at -3, 6. So are they going to touch at -3, 6? Yep. Okay, so -3, 6 is where they're touching, right there. Okay, and this guy right here is at 0, 3. And now what do I do? Now I do the distance between those two, the distance formula. Okay, I'm trying to figure out where they cross. Okay, I figured out where they cross. Now I'm trying to find the distance between them. How far apart is -3 and 0? 3. How far apart is 6 and 3? 3. And 3 squared is 9, and 3 squared is 9, and 9 plus 9 is 18. And that is about 4 point something.
Yeah.
4 point what? 2.4? Perfect. That's 4.24 apart. Now, does that sound about right? We said 6 was too much because 6 was right here, right? But if I go less than that, 4.24, that sounds about right, right? Because it has to be perpendicular, right? You guys can see that. You guys probably don't have to mark out all of your dots because you can see it better on your coordinate plane, but I can't draw straight lines to save my life. So there you go. Sure, there's rulers back there if you need them, okay? 14 is similar to that. So now you only have 6 homework problems left. Yay! Okay. And I think I picked the problems where they come out really nicely. Like not the answer, but like the dots are in the right spot. Sorry. Sorry.
What?
Okay. There you go. Beautiful. Goodbye.